Welcome back, everyone, to the deep dive today. We're going to be tackling something I think a lot of people find pretty intimidating, advanced math.
Oh, yeah.
We're talking about calculus, differential equations, all that kind of stuff that might make you think, I'm just not a math person.
Right.
But what if that's not actually true? What if that's just a misconception we've kind of told ourselves?
Yeah, I think that's a really important place to start. That self-limiting belief that I'm not a math person.
So why do we do that? Why do we create these labels for ourselves?
Well, it can come from different places. Maybe we had a bad experience with math in school or a teacher that wasn't encouraging.
Right.
But the thing is, math is like any other skill you learn. It's like learning a language or playing a musical instrument.
So you're saying even like the big name famous mathematicians, they weren't just born knowing all this stuff.
Exactly. They had to work at it. They faced challenges just like anyone else.
Like take Isaac Newton, for example. I mean, he's like the calculus guy.
Right.
He didn't just magically come up with all that, did he?
Oh, absolutely not. It was years of dedication, exploration, making mistakes.
That makes me feel a little better.
Yeah.
But let's get practical here for a second. How do we actually approach something like calculus without getting totally overwhelmed?
Well, I think the key is to shift our focus from just memorizing formulas to really understanding what those formulas mean.
So it's not enough to just plug in numbers and get the right answer.
Right. It's about understanding the why behind the what.
Interesting. So like with derivatives, for example, instead of memorizing the rules, what should we be focusing on?
Think about what a derivative represents. It's essentially a rate of change, like the speed of a car.
Okay, I can picture that. The speedometer is telling you how fast your position is changing.
Exactly. And that's basically a derivative in action.
That's way more relatable than just looking at a bunch of equations.
Right. When you understand the concepts, math becomes a language for solving real-world problems.
Okay, so we've talked about mindset and understanding the concepts, but there's no getting around it. Practice is important too. And sometimes, let's be honest, it can feel a bit tedious.
It's true. But think about it like learning a musical instrument. You wouldn't expect to play a concerto perfectly after just one practice session.
Yeah, you got to put in the time.
Right. It takes repetition and effort to build those skills.
So it's like training your mathematical muscles.
Exactly. And with practice, those problem-solving skills become more intuitive.
But what about when you hit a wall with a really tough problem? Those can be so frustrating.
Don't shy away from them. Those challenging problems are the ones that really push your understanding.
So even though it's tempting to just stick to the easy ones.
Right. You don't grow by staying in your comfort zone.
So you're saying lean into those challenges.
Exactly. And if you get stuck, don't be afraid to break the problem down into smaller steps or to ask for help.
That's a good point. Asking for help is not a sign of weakness.
Not at all. It's part of the learning process.
I've always found study groups to be really helpful for math.
Oh, absolutely. Study groups are fantastic. They give you a chance to talk through concepts with other people.
And sometimes explaining something to someone else is the best way to learn it yourself.
It's true. And you might hear different perspectives or approaches that you hadn't thought of before.
So we've covered a lot in this first part. Shifting our mindset, focusing on understanding the concepts, the importance of practice and collaborative learning. But I think there's another key element we haven't touched on yet, patience.
That's so important. Math, especially at the advanced levels, takes time and persistence.
It's not a sprint. It's a marathon.
Exactly. It's about pacing yourself, celebrating the small wins, and embracing the challenge.
So just like climbing a mountain, you don't reach the summit in one giant leap.
Right. It's about taking it one step at a time.
So for anyone out there grappling with these complex math concepts, remember, it's okay to struggle, to question, to even stumble.
Yeah, those struggles are part of the learning process.
Be patient with yourself. Celebrate those small victories. And don't lose sight of the beauty and logic that's at the heart of even the most complex math. But we've explored quite a bit in this first part of our deep dive. Let's take a moment to absorb these insights, and we'll continue our exploration in part 2 with even more strategies and perspectives on conquering the world of advanced math.
Sounds good. One thing that I think often gets in the way of really understanding advanced math is the way it's usually presented.
How so?
Well, a lot of times it's taught as just a bunch of formulas and procedures to memorize.
Right.
And while those are important, of course, I think focusing too much on that can make people miss the elegance and beauty of the concepts themselves.
It's like learning the rules of a game without understanding the strategy.
Exactly.
Yeah.
You might be able to follow the steps, but you're not really playing the game.
So how can we change that?
Yeah.
How can we approach math learning in a way that prioritizes understanding over just rote memorization?
One really helpful technique is visualization. Instead of just seeing equations as symbols, try to create a mental picture or a real-world analogy that represents what that equation is describing.
I like that. Earlier, we talked about picturing a derivative as a speedometer. What are some other examples of how we could use visualization to make math more intuitive?
Let's take integration, for example.
Yep.
Instead of thinking of it as just finding the area under a curve, imagine you're building something with blocks.
Okay.
Integration is like adding up the volume of each tiny block to get the total volume of the structure.
That's a great way to think about it.
Another powerful approach is to connect mathematical concepts to real-world applications.
So see how it's actually used in different fields.
Exactly. When you see how math is used in physics, engineering, finance, even art and music, it becomes much more engaging.
So it's not just an isolated subject, it's connected to everything around us.
Precisely. The patterns in nature, the design of buildings, the algorithms that power our smartphones, it's all based on math.
That's so true. Once you start to see those connections, it's hard to deny the power and beauty of math.
Right.
But I think there's another piece of this puzzle that we often overlook, and that's the role of intuition.
Absolutely. Intuition is a huge part of problem solving, especially in math.
But what do we even mean by intuition when we're talking about math?
It's that sense of knowing or understanding something without necessarily being able to explain why.
Like a hunch?
Exactly, a hunch that leads you in the right direction.
But how do you develop that kind of intuition in math? It seems like something you either have or you don't.
Like any skill, intuition can be developed through practice and experience. The more you work with mathematical concepts, the more you start to get a feel for how they work.
So it's about exposing yourself to different problems, trying different approaches, and gradually building that sense of what feels right or wrong mathematically.
Exactly. And as you become more comfortable with the fundamentals, your intuition will become a really valuable tool.
It's kind of like learning a new language.
How so?
At first, you have to consciously translate every word and phrase, but as you become more fluent, you start to think and speak in that language naturally.
That's a great analogy. The same thing happens with math.
We've talked about visualization, connecting math to the real world, and developing intuition. But there's another important aspect of learning math that we haven't really touched on yet, and that's the social aspect.
Right. Learning math doesn't have to be a solitary activity.
Yeah, we talked about study groups earlier, but even beyond that, it's important to remember that even professional mathematicians don't work in isolation. They go to conferences, they share ideas with colleagues, they build on each other's work.
Absolutely. Math is a very collaborative field.
And sometimes just the act of explaining a concept to someone else can help you understand it better yourself.
I completely agree. Teaching is often the best way to learn.
So whether it's through study groups, online forums, or just casual conversations about math with friends and family, embracing that social aspect can make the learning process much more engaging and rewarding.
And it helps to break down that stereotype of math being a lonely, isolated pursuit.
Right. It's about sharing ideas, sparking curiosity, and working together to solve those challenging problems.
That's a beautiful way to put it. Math is not just about numbers and formulas. It's about creativity, collaboration, and understanding the world around us.
You shared some fantastic insights. But before we wrap up this part of our deep dive, I want to circle back to something we mentioned earlier, the fear of failure.
Right.
So many people avoid math altogether because they're afraid of getting things wrong.
And I understand that fear. But the truth is, failure is an essential part of learning.
It's like learning to ride a bike. You're going to fall down a few times before you find your balance.
Exactly. And each time you fall, you learn something new about what works and what doesn't.
So instead of seeing mistakes as setbacks, we should see them as opportunities for growth.
Absolutely. Mistakes are valuable feedback. They help us refine our understanding and improve our problem-solving skills.
So it's about shifting our perspective from seeing mistakes as something to be ashamed of, to seeing them as stepping stones to deeper understanding.
And creating a learning environment where it's okay to experiment, to make mistakes, to ask questions without feeling judged.
I love that idea.
Yeah.
We need to foster a culture of curiosity and exploration, especially in math.
I agree.
We've covered a lot of ground in this second part, exploring the nuances of learning and understanding advanced math.
We have.
We've talked about visualization, connecting math to the real world, and developing intuition, and embracing the social and even the failure aspects of the learning process. Let's take a moment to reflect on these insights. And then in the final part of our deep dive, we'll explore some practical tips and strategies for making these complex mathematical concepts more accessible and enjoyable. Okay, so we're back for the final part of our deep dive into advanced math. We've talked about mindset understanding versus memorizing, the role of practice, and even the social and emotional sides of learning math. But now let's get practical. What are some things that people can actually do to make those tough math concepts feel a little less intimidating?
Well, one thing that can be really helpful is to figure out what kind of learner you are and find resources that match your learning style.
Because not everyone learns the same way.
Yeah, exactly. Some people are visual learners, some are auditory learners, some learn best by doing.
Right.
The key is to find what works for you and then look for resources that cater to that.
So if you're a visual learner, you might want to check out interactive simulations or videos that bring those math concepts to life.
Exactly. And for auditory learners, there are tons of podcasts, audiobooks, and lectures out there.
And then there's hands-on learning too. Building models, working with manipulatives, even creating art based on math principles can make it much more engaging.
Right. The important thing is to explore different options and see what clicks for you.
Another tip I'd recommend is to break down those big, scary problems into smaller, more manageable chunks.
That's a great strategy. Sometimes a problem can feel overwhelming if you try to tackle it all at once.
Right.
But if you break it down into smaller steps, it becomes much less daunting.
It's like anything else in life. Trying to do too much at once can lead to burnout.
Exactly. So set small, achievable goals and celebrate your progress along the way.
And another thing that's really important is to regularly go back and review what you've already learned.
Oh, absolutely. Math builds on itself. So
Yeah.
if you don't have a solid foundation, it's going to be much harder to move on to more advanced concepts.
It's like building a house. You need a strong foundation before you can start adding the walls and the roof.
Exactly. Make sure you're taking the time to solidify your understanding of the basics.
And finally, and I think this is so important, remember that learning math is a journey. It's not a race.
That's so true. There's no need to compare yourself to others or to put pressure on yourself to become an expert overnight.
Everyone learns at their own pace. Celebrate your progress and don't be afraid to make mistakes.
Mistakes are inevitable, and they're actually valuable learning opportunities.
Don't let the fear of making a mistake stop you from trying new things.
Right. And if you're struggling, don't be afraid to ask for help.
There's no shame in reaching out to a teacher, a tutor, a classmate, or even just searching online for resources.
Learning is a collaborative process, and there's a whole community of people out there who are happy to help.
We've covered a lot of ground in this deep dive. We've talked about everything from mindset to practical strategies for tackling complex math.
We have, and I hope our listeners have found it helpful.
Me too. As we wrap up, I want to leave everyone with one final thought. Math is a language for understanding patterns, relationships in the world around us.
It's a powerful tool for problem-solving, critical thinking, and unraveling the mysteries of the universe.
It can be challenging, but the rewards are immense. So embrace the challenge, cultivate your curiosity, and remember you're capable of far more than you might think. Keep exploring, keep learning, and keep pushing the boundaries of your understanding. Until next time, may your mathematical journey be filled with discovery and delight.